Like I said last class, if you like the inverse operations method and you're successful at the inverse operations method, go ahead and use it. But we're going to take notes one more time about the box method because for pretty much all of us, this is new. On this little picture right here, we have general steps for what's going to happen in the box method, specific steps for this particular problem, and then the actual problem that we're going to be solving here. Now we're looking for the value of x that makes this equation true. You would have said solve the equation. What's the solution? That's what we're doing here today. The very first thing we're going to do, and you're going to have to draw this in, is we need to draw a line down the center of our equal sign. It creates what's called a left-hand side and a right-hand side. Left-hand side is over here on the left, and right-hand side is over here on the right. Okay, I'm going to refer to them that way. These are just the steps of the box method written concretely for you when you study. Okay, so if you notice, the first line that's in the black bar at the top says negative 9x plus 6 plus 7x equal to x minus 9 plus 15. There's a lot going on. This is a complicated equation, right? This is truly when the box method is going to come in handy because that's a lot of moving parts. And the box method helps us put it in the right part, like it gives it a place to be. The very first thing you're going to do every single time you solve an equation is you're going to look for distribution. Okay, that's the first thing we're going to do. What do we know it looks like when we need to distribute? What am I looking for? Parentheses, very cool. All right, so here is a parentheses right there. And I've got what number in front of that parentheses?
9.
Negative 9. So everybody draw those arrows. Remember, those arrows mean multiplication. If you see those arrows that look like fireworks, you're always going to multiply. Okay, negative 9 times x and then negative 9 times 6, we'd end up with negative 9x minus 54. The rest of the equation, I write down again fully. Yes, you write it down fully. So here's what we did. The specific steps right here, we multiplied that distribution. We did this. Okay. The next step is to set up our boxes. In this problem, our boxes have gotten bigger because it's a more complicated equation. How many, in this line right here, how many terms or pieces of it have an x attached to them? 3. 1, 2, and 3. Do you agree? Look how many top boxes I made. I didn't just make 2, I made 3 because there's 3 things that need to go in there. Does that make sense? How many pieces up here don't have an x attached to them? 1, 2, and 3. So I have 3 boxes over here. I've set it up. Whew, good, check. They'll get bigger and smaller as we do different problems. Okay, the next step is to move all of your variables to the left-hand side and move all of your constants to the right-hand side. What I mean is you're going to move all of your variables to this box and all of your constants to this box. This is where you must draw your arrows, and if you do not draw your arrows, you need to, okay? Put a bunch of arrows on this one so you remember that's the arrow step. I need you to draw the arrows. Because if that arrow that you're drawing crosses that center line that you've drawn in, you need to use the opposite term because it's an inverse operation. So watch, we have negative 9x, and we have positive 7x, and we have x on the other side. All 3 of those need to come into the x side. But the x from the right-hand side crosses the center line, so I write down negative x. Does that make sense? Then I look for the constants, the regular numbers. Negative 54 would cross the center line, so it changes signs. Negative 9 and 15 do not, so they just drop down into the box. The next step here says to do what? What's the next row say to do? Combine like terms. What does it mean to combine like terms? Numbers. This is where it becomes vitally important that you know how to use that calculator. We are adding, though you might be adding negative numbers. In your calculator right now, I want you to try this. Type in negative 9 plus 7 plus negative 1. Hopefully it gives you negative 3. Let's just make sure we've got that calculator skill. Now let's check on the other side. So we would also add the numbers on the other side. 54 plus negative 9 plus 15. Let's make sure we've got those calculator skills. Did we get 60 when we added those things together? 54 plus negative 9 plus 15. Okay, that is the combining like term step, and you're going to utilize your calculator while you're doing this. We're almost done. The very last step in this box method that we've been doing is to isolate the variable. All that means that in this problem is we're going to divide. Most of the time, the very last step, like 99.9% of the time, the last step is to divide. And what number are we going to divide by? Negative 3. So in your calculators, I want to make sure you know how to do that. 60 divided by negative 3. Just make sure that you're not getting errors when you do this on your calculator. When you calculate that, you'll end up with negative 20. That's my solution. Okay, that's what we think the answer is. It's called a solution now. It's the value of x which makes the equation true. But we still need to check our work. Remember, we kind of talked about this earlier today on how to check our work. What do we do to make sure that that is the correct solution? What do we do with negative 20? So since x equals negative 20, we're going to plug in negative 20 to this equation. So I'm going to scoot up here for a second. And let's say I have negative 9, this is the equation, times x plus 6 plus 7x equal to x minus 9 plus 15. Okay, that's the original equation. Instead of x's, though, what can I put in their spot? What value did we just find? Negative 20. Okay, so we're going to plug in negative 20 to every spot that had an x. And then we're going to throw all of that in a calculator and make sure that it becomes a true statement. So right now, in your calculator, I want you to put all of this up to the equal sign in there. Parentheses and everything. Negative signs and everything. Plus signs and everything. I want you to press enter, and then we're going to see what number that is. Okay, so when we calculate that purple side, we should get negative 14. Now I want everybody to also calculate the other side. So I want you to type all of that in there. Negative 20 minus 9 plus 5. If, when you press enter, you get negative 14, we're good to go. Did you get negative 14? So we're left with a mathematical statement that says negative 14 equals negative 14. Is that true? Yeah, negative 14 is negative 14. Great, we got this problem right. I know I got those points. I'm good to go. I can turn in my stuff. You always can check your own work when you get an answer. And I'm going to ask that you do that today while we're working. When you get an answer, you're going to check it to see if you got it right. There's no asking me, did I get this right? You're going to check it yourself. If then you have it wrong, then you'll come to me and I'll help you, obviously. But I want you to be able to be independent here. Oh no, it didn't stick to each other. My favorite calculator. It's on the ground. Okay, so we're going to do this problem together. We're going to do number 35. This is the only one we're doing together today, and then you're going to work on your own for the rest of the document, okay? Until the very end, and then I got the very end with you.
Can we do the hardest one?
Honestly, this one might be.
Okay. Because usually we do like the easiest one, and then the next one is like super hard, and I'm like, what the heck?
Okay, actually, that's a good point. If we're going to go do the hardest one, we're going to go to the back side of this page. Is that fine with everybody?
Yeah.
Okay, so everybody flip to the back so we can do the hardest one together. That's going to be number 39.
Okay.
Oh my goodness. This is where the box method comes in handy. Do not panic, everyone. This question says, what value of n makes the equation true? We're solving for n. That's what that question says. What value makes it true? What can we plug in to get a true mathematical statement? Okay, no panicking, everyone. We all know the first step. Find the equal sign, draw a line. Whew. Step 2 is to look for distribution. Are there numbers in front of parentheses?
Yes.
Yeah, we have a 6 right here. And what number on the other side?
0.25.
Negative
so
0
really,
point, yeah.
We can really put 1/4 there.
That's correct. It's the same as 1/4, yeah.
That would look better there too, right?
I like fractions better.
Yeah,
Okay, so let's multiply these things. You have a calculator for a reason. What's 6 times 0.5?
6 times 0.5?
Uh-huh.
6 times 25?
Times 0.5
Oh.
is 3n. Very good. And then I'm also going to do 6 times negative 2. What's 6 times negative 2?
It's -6.
Should be negative 12.
Oh, negative 12. Oh,
Okay.
You're right. My bad.
Did I do anything with that 2n? You see the 2n I haven't highlighted up there?
Oh, yeah.
Did I do anything with it? No, I can't let it float away, so I'm going to continue bringing it down in the next line of my equation. But I have to distribute again.
Oh, that would be
What's
negative 1.
negative 0.25 times 4, you are correct, is negative 1.
Yeah.
And what's negative 0.25 times negative 8?
Negative 2.
It should be positive.
Positive 2. 'cause
Negative times negative is a positive.
I'm so sleepy right now.
Okay? That's the first step. All we've done in distribution. On the front page, what it says to do next is set up your boxes. I made this box big on purpose. Don't act like don't think I can't draw, okay? I did it on purpose. How many terms up there have an n attached to them? 3. So I need to make sure there are 3 places for n's to go. How many things up there do not have an n? 2. Awesome. It has 2 spots. 5 total spots for 5 total terms. Let's draw our arrows. Draw the arrows. Oh my goodness, draw the arrows. The 3n goes right here. No change. The 2n goes right here. Do I change it? It's positive, so now it's negative. This 2n from all the way over there crossed the center line, so it changes sign. So now I write negative 2n. What should I move next?
Negative 12.
And I move it over there. Do I write negative 12? Positive 12 because it crossed the center line.
Right.
What about that negative 1?
Positive 1?
Did it cross the center line?
No.
No, so it stays the same sign, negative 1. The center line is what you're looking at, and that's why we draw all these arrows. Okay?
So the 2 times negative 2 times negative 2 will equal. Oh, but you got to do them in order?
Doesn't matter. Well, we're adding, remember. So CLT means we're going to add these things together. So in your calculator, I want you to add those coefficients. 3 plus negative 2 plus negative 2.
Does the order matter or not?
For addition, it doesn't, as long as the signs are correct. Add them, the coefficients, the numbers right there, the big numbers in front.
That'd be negative
3 plus negative 2 plus negative 2. You are correct. Is negative 1n.
And
And then add the other side. 12 plus negative 1, 11. Great. I'm almost done. What's next, man? We will get to, so it'll be n's this time because we're using a different letter. But yes, right. How did I get there? What do I have to divide by? Negative 1. Great. So then my n, or x's, but we're using n's this time, would be equal to negative 11. And if we weren't 1,000% sure that this is right, we would check our work. And since we're learning together, we're going to check our work together. This is what I expect for you to do on every problem. We're going to take the original problem. 6 times 0.5n minus 2 equal to 2n minus 0.25 times 4 minus 8n. But instead of all of these n's, what am I going to write there instead? Negative 11. Now, when two things are smushed next to each other, they're multiplied. So I have to put it in parentheses so it looks like it's actually multiplied. But remember, your calculator is doing all the work here. You're typing all of this in up to the equal sign, pressing enter.
Even on the second one, you just go to the where?
Go to the very end. From the equal
okay.
sign to the very end. I want you guys to tell me what those come out to. So everybody's typing in their calculator. What is 6, open parentheses, 0.5 times negative 11 minus 2, close parentheses. Press enter. What do you get?
Negative 11.
Are you sure?
Yeah.
You're just like literally clicking buttons on there.
Yeah.
I was doing the math in my head like, is it negative 11? You're just
I don't know.
So we got negative 9. I'm trusting you guys here. And then can you give me everything else on that side? Type all of that in. And if it equals to negative 9, then we did this problem right. You don't have to ask me, did I do this right? You can check all of your own work. You guys lied to me. This isn't 9.
It's 3.
It should be negative 45, right? Negative 45 is correct. And when you do the other side, you'd get negative 45. Did anybody sit there going, I swear I'm getting negative 45? You were correct. Yeah, okay. Since negative 45 equals negative 45, that is correct. That's a true mathematical statement. So this is the correct solution. So here's what we're going to do for the rest of class. You have the rest of this worksheet, the front and the back, through example 40 to work on your own. In the last 15 minutes of class, I will go over this last little section with you. So hang on for that little section, but you are going to be working for the next 30-ish minutes on your own, trying to get through as many of these problems as you can, practicing these skills. This is the last day we're doing this skill, so let's make sure we nail it down. Yes? Okay, I'll get back to you in 30 minutes. Thank you for working so diligently for the last 30-ish minutes. We're going to get down to what are called special solutions. There are a few kinds of questions where your box method, your box method will end up with a weird answer. And those are called special solutions. Okay? So if I'm solving, like in example 41, I'm just going to go ahead and do this one kind of fast because we've gone over the box method a lot, and I just want to show you what happens at the very end of this problem. So let's say that I'm going and I have negative 2 times 36, which is negative 7.2. And then I'm going to add 1.6n. This is just distribution. And then I draw my boxes. There's 2 n's and there's 2 things without n's. I know I'm going fast, but I'm just trying to show you. Just follow along with me. You don't have to type or to write anything just yet. This would be negative 1.6n. This would be positive 7.2. And this would be 7.2. When I add those things together, I actually end up with 0n and 0, which is the mathematical statement. First of all, 0n, what? That's super weird. But this is a mathematical statement that 0 equal to 0. Is that true? Does 0 equal 0? Yeah, when that's the case, when this happens, when your variables become 0, and you end up with a true mathematical statement, this is called all real numbers. It's a way to say that every single number that we plug into that thing, when we check our work, they would be okay. You could plug in 5, you could plug in negative 5, you could plug in 8,321, and it would all work. Okay, let me do this other example before I give you time to write this down because I'm just going through it kind of quickly. But on this problem, we would again solve with the box method, which means we draw our line and we distribute across the entire equation when necessary. This would become 14 minus 2w minus 7 plus 4w equal to 2w plus 8 minus 15. And again, I know I'm going fast. I just want you to see what happens here. How many terms up there have w's attached to them? 3. How many do not? Are you sure? 4. What? I know, it's wild. So this is why we take our time. So we have 2w, or negative 2w. We have 4w, and then we have negative 2w. We toss all the constants over here, making sure if it crosses the line, we change the sign. And what happens is when we finish solving this one, we're going to end up with, again, 0 w's, which means your spidey senses should start going, uh-oh, something's wrong here, equal to negative 14. So we're left with the mathematical sentence that 0 equals to negative 14. Is that true? No, 0 is not negative 14. 0 is 0. So this means that not a single number we could plug in there, like when we, that's not how you spell solution. Let me try that again. It's embarrassing. There's not a single number I could plug in, like when we were checking our work, and this would work. This equation would not be ever true, ever. So it has no solution. There are going to be problems maybe 99% of the time that have an actual solution. Then there's 1% of problems that'll be like these. All I need you to be aware of, number 1, is how to solve with the box method, because that's all I've done. They're just complicated. But if you get 0n, or 0w, or 0 something, you have to know it's a special solution. The 0 in front of the variable, so important. You're either going to answer all real numbers or no solutions based on what mathematical sentence is left. Either a true one or a false one. If it's true, it's all real numbers. If it's false, it's no solution. The bell just rings, so we have about 7 minutes left in class. I want you guys to write down these 2 examples, and we're going to pass out your homework for the day. Thank you for hanging on all day with these complicated equations.